Life on Mars. Earth supports living things through providing proper climate and weather, which makes it such a beautiful place. As time goes on, people are increasingly concerned with the Earth being able to maintain a steady climate to support all the many species of life, with the rising population of humans and rising levels of greenhouse gases that may be uninhabitable at a certain point. Solutions for this predicament are limited, as no planets close enough to reach have shown any signs of potential environment for a living species, except for one, Mars, which has shown signs of water on the northern part of the planet. This recent discovery gives hope for the future, and more people have been working and organizing to reach this magnificent goal, like Elon Musk and SpaceX. This topic is fascinating as it could lead to something that would alter the history of our entire existence. It would also open new opportunities for future technology fueled by the imagination of commercial flight to another planet and contribute to a new uncharted land that could once possibly support life. The moon landing is just a stepping stone compared to the possible gains and achievements of the journey to Mars. Mars caught human attention for the first time in 1870 when an Italian astronomer named Giovanni Schiaparelli used a telescope and observed a series of channels on the planet's surface. People hoped Mars had sufficient water, or even some sort of irrigation channels of water, which is why it has always been more thoroughly looked at, also because of its similar seasonal cycles. Mars' rotational period and axis is very similar to Earth's, which is why the seasons are so similar. The difference is the rotational period around the Sun for Mars is larger, therefore making the seasonal cycles twice as long. In 1965, the first robotic spacecraft was sent to Mars, sent back 21 photos to Earth, and revealed a world that was unique, with similar craters to the Moon. This led to the Viking mission in 1975, in which 2 orbiters and landers were launched. The advanced landers were able to perform experiments that included a chemical test for anything that was living. Most of the scientists concluded the test results to be negative, which unmotivated scientists on Earth and slowed any further research on Mars until developments in new studies happened. Not until 1996, an announcement by a group from Stanford University and NASA's Johnson Space Center stated that a meteorite believed to originate on Mars contained what might be fossils from an ancient microbe. This rock, along with other meteorites, were discovered on different continents on Earth. They were thought to be broken away from meteorite impacts on Mars's surface. They believe this because gases are trapped in some of the rocks and match the composition of Mars's atmosphere. Despite only a few scientists agreeing with the theories and studies from the groups, an investigation on Mars was back in business. With our condition of needing water to live, did Mars ever have life on its own? In the 1990s, scientists were able to discover more about microbial life having the ability to survive under seemingly uninhabitable conditions, such as areas with extreme cold, hot, or dry climates, and even withstanding intense pressure. In 2000, NASA made an announcement of finding evidence of water on Mars, which throttled the investigation to find microbial life, or microbiological life, on Mars. Scientists started to theorize water being on Mars for billions of years in underground springs that could still exist under the surface. Mars is a cold planet with a thin atmosphere and would not be able to support water on its surface. Evidence of water on Mars is an extraordinary discovery that acts as a base point for all previous and future findings. A finding of multiple minerals such as hematite and geothite, which are minerals that only form with water, were made. Dr. Goestar Klingelhelfer of University of Maine talks of the geothite having properties that only form in water in any state, and how hematite is similar, but less likely to always form in presence of water. Only one form of water is on Mars, and that is in the form of ice. The The water is frozen due to it being so cold on the surface. Ice caps are located near the poles and mostly in the northern pole. Ice caps vary in size depending on the seasons throughout the year. As you can see in the figure, the diameter fluctuates dramatically when the temperature changes. During winter, the constant darkness causes the surface to get cold enough for 30% of the atmosphere, which starts to form into thick slabs of dry ice. When the surface becomes exposed to light again, the ice reduces. This creates intense winds that could travel up to 250 miles per hour, and large amounts of water vapor and dust come with it, creating large clouds, like on Earth, but much more extreme. Theories of living organisms on Mars with some evidence shows the planet was more habitable than versus today. Despite having little evidence of living organisms on Mars, the Viking mission in the 1970s had a small success of finding living results, but most of the probe's experiments came back with negative results. Mars does have some positive viewings, but also had a lot of downfalls that led towards unlivable planet. Since Mars is half on astronomical units behind the Sun's habitable zone, the water will remain frozen on its surface. There is little heat transfer going across the surface and has very poor insulation against the wind, so the planet also lacks a magnetosphere, and the atmospheric pressure is not thick enough to sustain liquid water. Mars consists of many mysteries that scientists have been unable to figure out because of the drastic changes of the climate on Mars. Over time, these mysteries will be solved with advancing technology and will hopefully lead to more scientific breakthroughs. The scientific community in the United States has been developing a lifespan blueprint that can help in understanding how long liquid water was sustained on Mars. Based on the green rock, olivine, or known as peridot, which is a silicate mineral that is rich in magnesium and iron found in volcanic rock on Earth. Life requires liquid water, and olivine dissolves in water as well. This can help scientists figure out if there was liquid water on Mars for a duration that could support life long enough to develop. Olivine has recently been discovered on Mars from NASA's Mars Odyssey spacecraft. Scientists have used this information in studies to build a model that introduced us to controlling the factors of pH and temperature levels on Mars. The amount of acidity or alkalinity is a highly controlling factor, and a more precise estimate awaits information concerning the chemical conditions on the Martian surface. NASA has sent probes to Mars to search for microscopic life. Scientists conclude that olivine could take about 1 million years to dissolve in water. Other researchers believe that Mars did sustain some aspect of a liquid water environment, but still unclear on whether or not these conditions could sustain some sort of life. Seasons on Mars are twice as long compared to Earth, caused by the rotation period around the Sun, which also leads to why it is so cold on the surface of Mars. The atmosphere is thin, being made up of 95% carbon dioxide, which is about 100 times less dense than Earth's atmosphere. Future discoveries are on the rise, with all the progress made in both information and technology, which brings excitement to see what the future brings, with more and more people on board to the mission to Mars.